This is video 10 for CS2124. This is not abstract and lofty and designer and terms and all that stuff. This is all about just the nuts and bolts. How do I even start? That'll be my question that I'll answer. How do I even start on program 6? I think you have to stamp your foot when you state it. How do I even start on program 6? That was you talking, by the way. I've already done it, but I'm pretending I'm you. And here's how I would even start on program 6. Review the videos. Look how generous I'm being. That means watch the ones that you haven't watched yet. That's a review. Review the videos, the program assignment, I know other disciplines call those prompts. I've got prompt. The prompt pocket in my mind is full. Prompt means something else in computer science. So review the videos, the program assignment, and the pictures. Of course, the pictures. I'll even put an exclamation point on that. In other words, get your mind around it. Don't just get in there and start typing stuff in at random and hope that it works. It's not gonna. You've got to go back and think about what it is all these things are supposed to do. Each operation. 2, get slist.h. That's the header file for your linked list class. And program6.cpp. That's the driver program that I wrote for you so you can test your class, see if it works. And I'm going to say into a special, make it special, a special P6 directory, folder, whatever you used to call it. Why? Well, as you know, we have crossed over now where some of our programs are more than one file. It's just easier to manage it if you're organized and have all of the files related to this one particular project, this one particular program, together in their own directory. Then you don't have to go through with tweezers and pick out which ones have to do with program 6 and which ones don't. Okie dokie. 3. Now here's really everything else is leading up to this. Write a complete slist.cpp file. Well, duh, that's the whole assignment. You write that, you've implemented the linked list class, and you're done. Except, I'm not done. I didn't put a period over there. Write a complete slist.cpp file with nothing but what are called stub functions. S-T-U-B, F-N, apostrophe S. Stub functions. And yeah, I'm going to tell you what those are. They are functions, and they will run. They just won't do anything. In slist.h, if I copied these correctly, and I hope I did, the slist.h, you got that for free. That's attached to email. There's an insert prototype. Void, insert, and then weird looking parameter, const, data type, ampersand, new item, barely fits. Close parentheses, semicolon. First of all, let me just quickly review what this is. Void means it's not going to return anything. We assume our insert operation is going to be successful, and as long as we don't run out of memory on the machine, then it will be. The insert is the name of the function. Const reference means we're passing in by reference, but you can't change it. So we're passing a new item by data type, which I believe at the moment is defined to be string in the header file. This is it's almost like a variable that holds some kind of a data type like an int or string or whatever, so that we can in one place change it throughout the entire program. So if you get tired of working with strings, you can go up in the header file and set data type to be int rather than string, and voila, you've got a linked list that holds integers rather than strings. But here's the deal. Const data type reference means we're passing new item in by reference, but we can't change it. We're passing in the address. This is to save space. It's possible the data type is something huge, like complete record of everything we know about a Transylvania student. Their GPA, their pictures, all that stuff. It could be a gigantic data type that's going on here. But rather than make a copy of that gigantic data type item that we're sending to the function, this says just send in the address, but don't let them change it. So it has the effect of passing in by value. It disables changes to it by that function, but it saves us space because it's only passing the size of a pointer. That was way off track. Another prototype up here that's much simpler. Bool remove. Void. Was it void? Yes. Void. Now, those are in the header file. So if you can't read that green, I apologize. I'll switch to darker green. That's black. I'll switch back to black for the slist.cpp. These you got for free. Those are in that header file I sent. So your slist.cpp, what it does, it implements those functions. If you don't have all the functions implemented, then your program won't compile and link and run. So I've got to have the void. And it's going to be a member function of class slist with a capital S. So it's got to have slist : Then it's got to have insert. I have to start writing smaller. And it's got to have all of that. Of course, the parameter type has to match. Const data type reference. New item. This is a big drum roll for a nothing burger. But then instead of a semicolon at the end, since this is the function implementation, that's a curly bracket. I'll try to make it bold so you can see it way over there at the edge of the board. So what we've done so far is just take the prototype, put slist : because this is inside the implementation file. These things are not enclosed inside a comforting set of curly brackets like all of these prototypes are. All the prototypes are inside the curly brackets for the header file, for the class interface declaration. Stumble, and I've had caffeine, there's no excuse. So here's the first line of the actual real function, that's why it has an open curly bracket. And it's not returning anything, so you know what, we're done. Close curly bracket. Ladies and gentlemen, we have ourselves a stub function. That's even uglier than the curly brackets I do in a real class. That is gorgeous, and I'm not going to touch it. Look at this. This insert function doesn't do anything. Not a darn thing. I almost used a bad word. But this doesn't do anything, and it doesn't return anything because it's not supposed to. But, the compiler's not going to complain and said you didn't implement the insert function. I did. I just implemented an empty insert function. It doesn't do anything yet. Go back through the video and count how many times I say it doesn't do anything yet. I'm sick of hearing myself say it. Let's do remove. Bool. Slist : you got to put some other may I out here. Slist : says remove is a member function of the linked list class, not a standalone function with a life of its own. Void, we're not even passing anything in. Close parentheses, and then an open curly bracket because we've got to implement the function. This is still going to be a stub function, meaning it's merely a stub. It's not a real function. It doesn't do anything yet. Okay. But it does have to do at least one thing. We promised the compiler we would return something. If we don't put any other lines in there, is remove going to remove anything? No. So we're going to fail. Return false. That's inside slist.cpp. You could do that for every single one of the member functions of the linked list class. Why? Why would you do that? Well, you've actually done some stuff that is going to be part of the final version of your slist.cpp file. And now you can go back at your leisure, almost like you're accessing array elements, and implement one function at a time as you figure out how to do it. Now, some of them you are going to have to do in order, so to speak. In other words, until you do the insert function, you're not going to get much out of the get function. So there's no point in even trying to implement get until you've already got an insert that's operational. So it's not quite like an array. I take that back. You can't do them in just random order. You do need to do them in sequence. But you can do it incrementally, divide and conquer. You can do them one at a time, compile and link and run, and convince yourself that that member function is doing what it's supposed to do. And then you go on to the next one. Step 4, that I hardly have any space for, make sure your project compiles and runs. Now, if it's nothing but stub functions at this point, that's all we've done so far is write stub functions. It might very well compile and link and run. And project just means now it's gone beyond program. A project is where we've got several files. And we do. We've got the main program file. We've got the linked list implementation class. Make sure that that compiles and runs on your system. Now you're ready to go back in. And, well, you know what? I slipped in a step in here. 5. I'm compelled by my nature to put 5 up here. List all class invariants in the slist.cpp, slist.cpp header. Comments. A list of things, a list of rules by which you must abide. The cursor always points at some node. The last node in the list always has 0. List all class invariants in the slist.cpp file. And you might think, well, Dr. England, you're just shoving some of your responsibility off on us. You should have put that in the header file. The header file is what's publicly visible about this class. We've got to expose the interface. We've got to let the main program know what functions are available. If you think about it real hard or even real soft, the class invariants are only known by whoever is implementing the inside of the mechanism. They're the ones building the inside of the TV. They're the ones that have to know how it works. The class invariants should not, they better not, make any sense to the main program. The main program is blissfully unaware that such a thing as a head pointer or a cursor pointer or anything like that even exists. That's none of the main program's business. So the main program doesn't have any say in whether or not the class invariants are enforced or not. That is rules for whoever is implementing the class implementation. Then 6, I barely got room for 6. Implement and test each function one at a time. And that's it. Do them one at a time. Test and make sure each one. And when you do one at a time, one foot after another, before you know it, the whole thing will be done. Let me read back through this. It doesn't match my notes exactly. Let me see if it makes sense. Review the videos. Yes, you want to do that if you haven't watched them yet. The program assignment that I sent in the email, and look at the pictures. To get these 2 files out of the email and into a special folder that's going to be your workshop folder for this program. Then you write your own version of slist.cpp, where basically this is all, I'm going to claim this is all pretty mechanical stuff here. You can just copy and paste all of those prototypes out of the header file into your CPP file and change them from prototypes with a semicolon to stub functions with pretty much empty curly brackets. If you promise to return value, bool, return false. You're not doing it. Promise you return an integer, return 0, whatever. All of these stub functions are going to be at most 1 line. Several of them might very well be completely empty. Make sure your project compiles and runs. That is a check to make sure that you've got all this stuff correct. You got all the parameters typed in correctly, the names of the functions are correct, and all that. That's going to have to be right anyway. So you're not wasting your time with this stuff. This is not stuff you're going to go back and remove. This is just incrementally building this by fleshing out an outline of your program. List all the class invariants at the header comments for your reference. I know they all just seem like intuitively obvious observations at the moment. Well, of course, we're going to have to do that. You're going to want to have that handy for no other reason because I'm going to look for it and make sure that it's in your header comments. Then you implement and test each function one at a time, and then you get to do this. You get to check the box. Program 6, done and done. Just like this video. See you online.